Sorry guys, for some reason I don't hear you at all, so just trying to get your audio working.
Hello, hello, hello.
Oh, say something please.
Hello.
Oh, hello. So, yeah, sorry, due to having all this stuff rolled out at home, I had to make additional preparation for that. So, hello everyone again. I'm just going to ensure that audio works well. So do you hear well? Please confirm.
Yes.
Yep.
So I think potentially you can be not on mute if it is not allowed at home, because I don't hear any noise when you turn on your mics, so it can simplify. If I have longer session of monologue, you can switch off the mic, but currently maybe I will be asking some questions. So it is also important to hear from you. One additional thing I'd like to check is the quality. This is a whiteboard I'm going to use, so I need to be sure that you see details well enough there. So let me check just with a small character. I need to such a size of text, is it readable or not?
It's readable.
Just barely.
Yeah, but it would be good to have it a little bit more, yeah.
Okay, so it's so like this, right?
Yes.
It's better.
Yes.
Great. So this is the next step. Additionally, during the session, we will have some materials I will be showing as a video. For that, I have two possibilities, like to share something with you by link or using this screen. So sometimes I will be doing both. Is it okay? I hope you see the screen well.
Okay.
A little closer. Seems to be. So for me, it seems to be written. Okay, so let's start with organizational stuff. So hello again. My name is Alexander. I'm going to have like 24 hours session of lectures now. It is split into 3 parts, 3 days. And every day we will have 8 hours of lectures with break in the middle. This break can be from 1 to 2 hours, depends on us. And this will be dedicated for a bit of rest and maybe lunch or something. We have corresponding syllabus. We have corresponding documents who I am, but I want to introduce myself before we continue, like verbally. So for about 8 years, I'm working exclusively with artificial intelligence based projects as a software engineer, AI engineer, and currently I have a small team company we call AILabs.org, call ourselves, and what we do is consulting, implementing, and delivering many AI-based projects. It is computer vision, it is natural language processing, signal processing, forecasting like weather forecasting and so on. For different areas, starting from energy to like economics-based things. So this is quite a big range of things we can work with. And applicability of AI-based technologies is quite wide. We can use this in many different fields. This current course is specially dedicated for computer vision things. And what we are going to talk about is what we can do with pictures or video we obtain by cameras from any source, like drones, webcams, maybe some security cams in shopping malls or outside, outdoor cameras. Sometimes it also can be relevant for documents, reading optical documents, reading optical character recognition, and things, everything is related to image processing. So we will have many examples here. I will be talking about study cases. Also, I'm going to talk about things like some basics of implementation, how it can be done, and you will have a chance to have your hands dirty with coding. But as a special request, I had an email about that I shouldn't be concentrating a lot on math. So I will try to keep a balance between business things that can be got from AI things, and of course math and scientific background for that, because there is no artificial intelligence without computer science and things like this. I will just try to simplify and deliver things in a way that is applicable for a common audience. Yeah. So today, according to our syllabus, we have to talk about machine learning and computer vision in general. We also will go through several case studies. And tomorrow, we will primarily be talking about mathematical and scientific background for that, how neural networks work, particles and parts that are formed these neural networks, how we train neural networks, what it means to be trained for neural network, and we will have a small example. You will be able to see things like very simple neural network trained. You will be able even to develop it if you want. And also, in addition to that, we will be dealing with already existing solutions. You will be able to roll out this in Google Colab platform and check how it works. You will be able to record some video, get it from webcam or download from somewhere, or images, and check how computer vision can work in action using your own Jupyter Notebook. Regarding Jupyter Notebooks, it is a platform, absolutely open source and free of charge platform. You can use it for writing some Python code, so that Python is crucial thing here. So we cannot avoid using any Python. We will be using it. Also you can use all the universe of libraries, tools, scientific tools that are available in Python world. So what you need to know is like Jupyter Notebook. And its free version hosted by Google. It is called, one important thing with one L here. Actually, I hope here in Zoom we have text chat. Let me find it. Yeah, I will be sending links here. So the first link you got is the link to Google Colab hosting. They provide a special platform where they have this Jupyter Notebook platform rolled out. What you need is to be logged in with your Google account. It is necessary. So if you have one, please log in. If you don't have one, please create your account. Google, I hope everyone already have Google accounts. It's like mandatory things for everything nowadays, I guess. So,
Sorry, can you repeat what should we do? Because it's low quality of sound.
sorry?
Can you repeat what should we do with that link?
Let me check if I'm using the proper mic, because I hope that my Jabra, this one, should be working well. So, yeah, let me check. What other reason? Oh, is it better now?
It's different.
Because it will, it happened to be like previously we used cameras mic.
Yeah, it's better. It's better.
Is it better?
Oh, yeah.
Yes, yes.
Yeah.
So sorry guys, I was thinking that it is already like Jabra mic. Okay, so Jupyter Notebook link here. For now, it isn't something that you should do something about immediately. This is just a like tour about tools we are going to use. This Google Colab and Jupyter Notebook allows us to use Python without making any additional installations on your laptops. We will be using this system for everything. You won't need to have it installed like, actually this is not a proper webcam also. No, it is. Okay, let me put the camera like this. Okay. I have many webcams, sorry. Need to realize which one is working. Here in Google Colab, you are able to create documents that are stored in your Google Drive. And these documents have extension IP1B, and they can be used for adding there some textual information, some Python code, and run it in this tool in place. so that you won't need to have Python installed on your laptop or so. I want you guys to try this, like maybe to spend a couple of minutes, like to create a doc and to see that you can write something like make it run and get the result. But this is the only thing I want you to check for that before we continue, because we will be using Colab later a lot, and if any questions, we will be able to solve it. Let me share the screen, and I will do this together with you.
Okay, I have it.
Okay, it works, right?
Yep.
Is there anyone here who tried this before? Google Colab.
No.
Actually, about that, I have a question about prerequisite course that you got before. Do you have statistics or math or something with Kyiv School of Economics, like maybe a previous course or something? Maybe you, Valentina, can tell me a little bit more about that.
No, Valentina, but yes, we had statistics course.
And not only statistics, we also had introduction to AI, yeah, and there we also worked with the Python and with Jupyter Notebook, yeah, but so it was not Colab.
Yeah, I'm just trying to ensure that you have already had some experience with Jupyter Notebook. Yeah, the reason why I want you to use Google Colab instead of Jupyter Notebook is that you won't need to install anything on your laptops. Also, another reason for that, some computer vision algorithms and libraries, they require to have powerful GPU installed in your system. And for many laptops, it's not the option. But Google Colab, they provide this platform with possibility to turn on GPU support for all these notebooks, so that we will be able to use all the power of libraries like TensorFlow, Keras, and PyTorch with GPU support. You can find this option here. Actually, share the screen. I'm wondering. Yeah, I see. Do you see the screen now?
No.
Yes.
Oh, yeah. Yeah, I do now. Yeah.
So let's create one, or even open one. So what you see is already existing IPython notebook here. Actually, computer vision things, as you can see. And here in a runtime menu, you can change runtime type for GPU. When you do this, you get the environment with GPU, and you're gonna run your computer vision based code much more quickly. So this is also for future.
Can you share with us what is TPU?
A little bit later, I will be talking about that. GPU is just a graphic card, regular one, provided by NVIDIA, something like RTX 2080 Ti, something like this, yeah. I will share additional info later about that. Okay, seems to be set up with tools now. All the details about Google Colab will be available later. And now let's talk about computer vision in general. I'm not sure that you see my whiteboard. Do you see it now? Perfect.
That's okay.
A small overview about AI and where computer vision is in AI ecosystem. And then we will be talking about what this computer vision actually looks like. So AI / ML, machine learning, is like a couple of terms people discussing a lot now. And the real thing is that AI is something that exists primarily in academia, but not in real business. This is quite virtual term because there is no formal definition of what is artificial intelligence. Many algorithms that used to be AI 20 years ago currently just considered to be part of regular computer science. It's usually something that people think, oh, we have a new algorithm and this new algorithm is capable to solve something that closer to what people can do, and this is the reason why people call this AI. But it isn't like that. AI is something that cannot be very strictly defined. No one knows what is AI. We know that finding the best route between two cities used to be artificial intelligence. Currently, it's just a short path on a graph or something. Ability to recognize a face on photo or something, is it artificial intelligence or not? It's a big question, but it is definitely can or can not be machine learning in some cases. Machine learning is a more formal term, and it means that we can provide our algorithm, our machine with some data, and this data-driven approach allows us to find new ways how our software behaves to solve our problem. If we need to describe and program all the behavior for all the programs by hands, sometimes it becomes impossible to do nice work if we have many details, many different small cases, how programs should behave dependent on data structure, on maybe statistical things like distribution or like specific of this data. And it is in common case in general, it is impossible to understand each detail of data and explicitly describe any possible case. Instead of that, people use algorithms, which we call machine learning, that can take data as an input, analyze this data from many different perspectives, like statistical things, distribution. Maybe if we are talking about images, we can analyze their size, their color depth, many other things. If we are talking about other types of data, some other statistical things, but we can take data, analyze them for statistical things, and then use many special techniques that for sure can be called machine learning, that learns something from data and store the result knowledge in memory, in computer memory. And then when we use some program that can utilize this knowledge, we call this, we have the machine learning model that can make our software work according to the nature of this data. Can be from very different domains. Currently, we are talking about computer vision, but to be honest, each domain, each area where we can get data from, whether it is astronauts provided or maybe industry provided data. Whenever we have data, we can use statistics and machine learning on top of this data, especially when we have good enough data and big enough data to be like informative enough. Okay, so primarily we will be talking about machine learning, and in this machine learning, the main topic what we are going to mention is CD, computer vision, and we will be mentioning other like domains, maybe like natural language processing or maybe signal processing in those situations when it is somehow related to our computer vision topic. The thing is that between domains, we have different type of data, but the same math as a background. So currently we are talking about computer vision, but when in a month we will be talking about natural language processing, we will find out that many algorithms and approaches we use for computer vision are also applicable for natural language processing. And the idea of neuron or neural network for computer vision and natural language processing, they have the same basic background theory. Also, we will be touching computer science topics. But not a lot. And tool set. We already discussed Jupyter, and you know Jupyter notebooks. Yeah. But in addition to that, we will be discussing many libraries that provide us with mathematical power from Python world. And they are NumPy, Pandas, and many others, like, let's say, TensorFlow, etc. Regarding domains, we already mentioned that, but I want you to make notes about this. In any domain, there is a certain specific about machine learning, of course. So having the same math and background doesn't mean not that working with machine learning for any domain is absolutely the same as for another domain, because we have data, and this data should be converted and used in very wide um, set of different ways. Sometimes we should process images, and this is already the difference for computer vision. Sometimes we have sequence of stock market changes. Sometimes it is textual input, and even on this stuff we have a lot of difference. So domain-specific knowledge about machine learning is very important. And for computer vision, what we are going to learn is to basic image processing, very common, very nice stack of technologies based on convolutional neural networks. Currently, I use abbreviation for that. You will be familiar with this abbreviation later, and I don't want to spell it completely here, but in our presentation later, you will see full name and set of that. Also, currently, there is not a thing like just a theory or something. We use a lot of real achievements in production for many projects. And these achievements primarily based on architectures that shows their performance well. For example, if we want to be able to distinguish buildings on photos or make our self-driving car to be able to distinguish cats from dogs, from pedestrians, from columns, from trees, from houses, and understand where the road is, and all the signs that camera sees. Sorry, just a moment. Something has happened. Some noise from someone. Do you hear me well? Do you hear any noise now?
Yes. No noise. I don't hear noise.
Just a moment.
No noise.
Okay, so regarding architectures, for all these tasks, we have already available set of the models that can be recommended for everyone to be used nowadays because they are called state of the art. Throughout maybe 8 years, we have many achievements in computer vision. Like each year, we have many competitions, many different products on the market that show nice result. And if we have something that shows better result than all we tried before, this becomes a state-of-the-art machine learning model. And for computer vision, this is the same. So usually we have some set of architectures, approaches that is called state of the art for computer vision. So we will be mentioning like different names of neural networks and architectures that show nice result in image classification, image segmentation, maybe optical character recognition, and so on. And this is important part because our case studies, they all based on already known nice architectures. Each architecture isn't the final solution, but instead it's like a set of libraries and recommendations and general implementation plan. But finally, when we need to implement this architecture in production, we need to develop many things and fine-tune this model for our needs so that we can get a nice result for our specific, very specific domain, much more specific than just an ability for recognize human being. Because for example, if we talk about general possibility of detecting is there a human being on the photo or not, it's one thing. But if we need to adjust this for our specific situation, we have this type of security camera and this type of space, and we want to be able to see people of this type working like this and in this light conditions, we can sometimes change architecture a little bit or retrain the model to make it more applicable for this very situation. This is also we are going to experiment with. You will be able to check some architectures using Google Colab. Yes. Okay, so one important thing for that is math background. And despite of this request not have too much math here, we cannot avoid all the math. We still need to understand what is machine learning model in general. Also, we need to understand what is neural and neural network. Oh, it's markers cannot work for a long time. Okay, neural network. It is mathematical thing. It is mathematical function. We usually think about neural networks like about something that that is mysterious and a little bit unclear what it is internally under the hood. But under the hood, it is a set of matrices and linear algebra applied to these matrices. Neural network, neuron structure, and of course, what is the neural network training process? Here we're going to mention things like backpropagation, inference, activation functions, and so on. So generally, this is the picture of what topics we are covering. And let's start with actually case studies. I'm going to show several screenshots, reports about different computer vision projects and research. We can discuss this, but before we start, about general things. For now, is it clear what is this course about? What we are going to discuss? And maybe you have some requests to cover something that you were thinking of before, but I didn't mention during this intro.
No, it's clear.
Fine for me.
Oh, so. Right. Let me take a photo of that. Do you know the application called Cam Scanner? Because this is a good example of computer vision things. Do you see what's happening on the phone, right?
No.
No.
I'm taking the picture of the whiteboard and automatically can convert it to a nice image. This is already computer vision based thing.
We can see it.
because of light conditions, right?
Yeah. What is the name of the app?
Let me show you. It is Cam Scanner. It's not. I wouldn't recommend you to stick to exactly to this application because there is a corresponding solution from Microsoft. I liked it from Ebby, but this is the one I'm using. The thing is that in this type of applications, they use several computer vision techniques that you can be potentially interested in, because you can use this functionality in your business solutions if you want. You can take regular photo of your document or some whiteboard, and computer vision allows you to understand that it is what's the angle, what is important on this image or not, like adjust the image to make it like nice scanned document, not just a low quality photo. Let's go. Today we're going to cover like just examples of let's start from that. So without digging in depth what and how it is implemented internally, I'm just going to show you several reports about research for this project, and you will be able to see and discuss with me business applicability of these solutions. So the first one, I call it an aerospace photos analysis. We did this for several customers, not just for one. Currently, we do this research for Japanese client. Oh, one important note. Tomorrow, maybe in the morning, we will also have an external speaker. His name is Hiroshi Shibata. He's one of my Japanese clients. And he will be talking about artificial intelligence-based projects that we worked on together, and in general, the demand for AI-based projects in Japan, and how it goes with this need to Ukraine, and to show here in Ukraine what is, how it can be used maybe in Japan, how we can build business between Japan and Ukraine in implementation, and maybe outsource and maybe product, but anyway we can do something interesting about AI together with Japanese industry, because Japan has a third large economy, and they have a lot of demand for technologies like this. So I'm sharing the screen. In a couple of it's not too fast, sorry. So you probably have a chance to see the screen, right?
Yes.
Yes.
So Google Maps, for example, Google Maps. Let's switch to satellite view. All of you remember what is Google Map. Many of you use this thing. So this is the set of photos from satellite. These types of images we can obtain using like satellite camera, aircraft-based camera, or even drone-based camera. And what we can see here is any type of landscape, including industrial or inhabited regions with buildings and something that can be interested for analytics. This analysis of these photos can be very important in many different areas, but I'm not going to talk now about like ecologists and biology, and so currently we want to be able to do something about photos of cities. We have buildings, roads. Everyone knows that for now many parts of the world are already covered with many additional layers, like layer with buildings, roads, maybe some additional things provided by Google or other vendors who implement geographical software. And what they use for that to deliver this result is like two types of effort. On one hand, they have people who do this annotation and mark down for photos, adding layers. But also they have automatic tools based on computer vision and AI that can find roads, buildings, and help annotators to add corresponding info to the map. And when we have such an input, and what if we need something to do about analysis, for example, buildings or roads, we need to be able to analyze buildings independently, roads independently, and so on. So, for example, when we have an image input like this, what computer vision can do for us is to convert this type of image at the first step to this type. So this operation is performed by neural network. Neural network gets as an input image itself, and then converts this image to new one that contains only things that are important for us. So this one removes everything that isn't a building, but for buildings, it tries to highlight um, like roof parts and roof edges in different colors. This is already taken from research and production. This is not like a virtual picture. So you will be able even to try this model, I hope. At least I will share the possibility for you to check how it can be done for satellite images. And the thing is, in order to make it possible to take the image and convert it to image that contains only important information, we should provide our system with information about what is important for us before we can use it. For example, for this situation, we had to create a special data set that contains many original images. And finally, special annotation, special result examples that shows that from this image we are interested just in this type of objects. When we have these examples, we can feed these examples to machine learning algorithm, and machine learning algorithm finally is able to do something for us. So this is how ideal result would look like. This is our annotation. So we take this photo, and for this photo, create this type of annotation. We do this for several thousand images, and as a result, the system becomes capable to do this thing automatically for any object. When we have this type of output, we already can analyze this using some algorithms that are able to understand where is the edge, where is the roof part, and let's say build some two-dimensional plan of the city, including information about where about coordinates, geographical coordinates, I mean Earth coordinates for each building, and so on. The same operation can be performed for different types of objects. Let's suppose we are interested in roads, so that we prepare data set where we have all the roads annotated. So we have original images with roads there, and result images. Result is like something that people initially prepare with highlighted spaces where we have roads on the picture. Machine learning algorithm takes this as an input, and after some analytics, we get a machine learning model that can be deployed maybe on server or even on drone, and the system will be able to see all the roads. So flying drone will be able to see the web of all the roads it sees with its camera. Now, this is just an example how it can be done for low quality images. But as you see here, even for this type of quality, our brain sees quite a lot of information about the form and geometry of each building, right? So we can guess how this building should look like, at least in two-dimensional form. To be honest, even in three-dimensional things can be like guessed, like using this input. So let me show several examples for you more about it.
Was it your project?
Yeah. One important thing is that everything I'm going to talk about in this course, it was implemented by AI Labs.org or AI Labs.org with partners. So nothing from external things. Actually, this project, it is still in progress. And the final goal for this is to provide a set of instruments that will make it possible to use just one drone flying on top currently Japanese landscape. And what we can get as an output is the map that contains buildings, roads, all water resources like rivers, lakes, not puddles, of course. Distinguish forests, lawns, and some objects like mountains, maybe things like separately placed trees. So the map will contain this set of objects automatically, and with preserving things like geographical coordinate, Earth coordinate, longitude, and so on. And one important thing about tools like this is that not only GIS system.
Yes.
Sorry?
GIS system.
Yeah, GIS. We call it GIS in simplified form. Yeah. Yeah, and also other things. For example, very important application for this is forest control. Let's suppose we have big forest somewhere in US or Canada or Siberia. These big countries have many like forest-based resources, and they have special departments to control forests, to observe what is happening there, how the landscape changes all throughout the time, maybe daily or hourly. It's the thing that cannot be done easily because it is too large to be like controlled by people. But the thing is, we can design a drone-based solution that flies on top our forest daily, for example, and recognizes the form of forest, including separately set trees and trees that like join together into big forest covered areas. And when we know how it was a day ago, and we fly today and see any difference, system can generate some alerts, alarms, let's say events, and send even emails to somewhere if we recognize things like missing trees. Maybe someone has stolen the tree, or the tree has fallen, and this place should be like serviced by forest source. Or maybe we see some illegal constructions inside the forest. Someone removed several trees and started building there something.
Forest fires, I think, important.
Yeah, regarding fires and natural disasters, it's an additional branch. I will mention this also today because it's very important. So
it is inexpensive solutions with drone using. There is more cheaper way to do it. Do forestation management and stuff like that. For example, ArcGIS can use satellite images in high resolution.
Yeah. Satellite input works well for that. If we have one, it's okay. If we don't have one, it's actually, this is also the question of resolution of images we have and detailization we need. If we need to analyze something in like larger scale, it's okay to have satellite-based input. Actually, this solution, what you see, it is built for satellite. It's not for drone. Yeah, but currently we also build thing for drone that sees like smaller details, because drone flies. The altitude of drone is about 100 meters or 150 meters, so that drone can fly without any additional regulations, legal regulation. If it flies at higher altitude, it needs special license and things and so on. So if drone flies like 150 meters, it can see a landscape in much more detailed way than satellite. You understand? Satellite-based camera. You understand that?
So what tool do you use for cleaning this LiDAR cloud points? Is it microstation?
No, it's a completely machine learning based solution developed by us. So nothing external. We use Python, TensorFlow, PyTorch, things like this, and data set. We also label special data sets, prepare data. So this is just one of examples of how this can be done and what we can do about that. Let me show one additional document for that I wanted to share with you. While I'm searching for the doc, what I wanted to tell about is specific drone characteristics that we use in Japan. It can cover 400 miles a day. So it has quite nice performance about that. And the corridor width is about maybe 200 or 300 meters. So this type of corridor length 400 miles and this area is covered by drones, so generally we can use one drone for controlling quite big forest or inhabited place. Yeah, let me check. Cannot load the link, just a moment. Okay, a little bit more additional screenshots for there. Just to see what can be done with even lower resolution images about that. The system sees all the edges and splits different roof parts automatically. And this is done completely, exclusively, only by computer vision and machine learning. no any algorithms and logic written by software engineers. Only computer vision things. So we get this image as an input on the left, and get one of the variants like this or this as the result. This is also several examples. As you understand, the final goal is to have a parameterized two-dimensional, maybe DXF format file or something. So we will be checking this technology later, and let's switch to what we can do with people tracking and object detection things. Actually, I should people tracking maybe.
Can you go back to the black marker?
Oh, sure. I can use blue one because it is like
Better contrast?
yeah. Is it better?
Much better.
Yes.
Okay. So the next part, presentation about what we can do for business with computer vision for shopping malls. And not only for shopping malls. Actually, the part I'm going to show to you is kind of report for one of the potential customers, and it's better to share the screen and understand, but maybe it's not as easy. So I hope. And I'm just going to show a video here. Yeah. I want to show some video for you. Have a link, nice link. This is one thing. And this is another thing.
Is it possible to share via desktop? Because the quality.
Yeah, okay, let me try. I need to send links somewhere. Let me.
I think it will be difficult to recognize some differences.
Yeah, okay, let me try. It's not easy for me to estimate the final quality. So yeah, if you don't see, please inform me. I'll try to fix that. It's a different laptop. That's why it's not easy to do it immediately, but I will try. Okay.
maybe to connect
Yeah,
remotely
yeah,
to it.
I already prepared something for you. Do you see the screen?
Yes.
Cool.
It's another computer vision based solution. This is real Kyoto station recording, a couple of. Fortunately, there is no such a strict regulation in Japan as in US, or there is no a strict analog of GDPR for Japanese market. So for Japan, we can leave such recordings for our needs. For European market, it is impossible, unfortunately, to even for this types of videos. Yeah. So what is happening here? You see the red and blue caption. It's counting how many people cross the green line one way or another way. Also, what a system is capable is to track exact human coordinates, understand where is this person exactly on the plan. Also, we can estimate age and gender of people with some kind of error, of course, but if we have at least 10 different shots of the same person, and you understand that on the video we have many of photos, each frame is the separate photo. We can detect age and gender for person in bounding box, for example, 5, and then
Hello?
Sandra, are you here?
Hello.
hello,
We're gone.
really?
Yeah.
And how do you hear me?
I can hear you now, but cannot see you. The
What's
last one I heard was bounding box 5.
Okay, sorry, I didn't do anything for that. Maybe it's Zoom make me. It says me join the meeting, but I am already in. So you saw bounding box 5, and that's it, right?
Yep.
And you don't see the screen now, right?
No.
No.
So let's finish with that. So generally, it's clear what's happening here, right? The number that flows together with bounding box is an ID of a person. So the system tries to re-identify the person using only person's appearance, clothes, type of things that person carrying hands or having some hats, maybe sometimes considering food, like maybe shoes people wear, and that's it. So nothing about even trying to compare. Sorry?
Excuse me, could you please tell me again what is red and what is blue?
It's counting of people who cross the line. There is, of course, some accuracy limit here. So when someone crosses the line, the system should increase this number. Like when we have people crossing down green line, we have this number increased. So you see, and if up, it is for red number. Yeah. So let's see this 157. Will he cross the line or not? Okay. So accuracy is is a thing that all the time under improvement for any machine learning based solution. There is no any solution that have 100% accuracy, but accuracy can be good enough to be applicable for business solution. For example, this type of tracking primarily is used to in order to get some statistics how human crowd walks in general. So what's the general flow lines of people we have in certain train station or shopping mall, and using this information we can analyze maybe something for marketing or for security or whatever. Yeah, so this is another solution. And for that, I will share with you models and approaches how to find people on the video and on single shot. You'll be able to check these models and use them. So I'm stopping screen sharing now. Okay. Another one small example about object detection and how it can work for any input, for any video. Just actually don't have nice video here. Did you hear the sound?
Yes.
It's from a video I wanted to render for you. Okay. Let me find my recording in the web. Some internet lags, sorry, cannot speed up. For some reason, I found out that during this period when people are staying at home, internet connection goes worse.
Perhaps I'm going to go make myself a coffee. I'll be back in 2 minutes.
Okay, great. I decided that I'm looking for the way to download this file faster. I will share something with you. Just try to see that. Do you see the screen?
Yes. Camera.
It's our team working on a machine learning project. This is the type of cameras we use. So they are accurately.
I have returned.
People are working just in order to check the quality of how we can track them. Here you see a couple of cameras observing the space and the small plan of the space with human coordinates and flow lines, how they walked. So they are walking just in order to have some information to be shown on the screen. It's a prototype, but generally this technology went to production in several businesses already.
And what's the business application for this?
Um, uh, this is primarily for shopping malls because they really need information about how people walk in shopping areas for different marketing and merchandising things.
Okay.
Okay. Well, I wanted to show for you guys cannot be downloaded. I don't understand why. It just cannot be opened. It is on Google Drive, but cannot be pulled here. I think I will be able to do this like during the break or something, because I wanted you to see that. Okay, it doesn't work. I will download it later when it works. Okay. Let's switch to discussion of how we can analyze input data. I stopped the sharing, right? No sharing.
Mhm.
Yeah, back to you.
Is green okay?
Yes.
I can actually pull the camera closer. Maybe. It might be better, right? So let's talk about what is the image as computer understands it. For us, it is of course the thing that looks like this. And this is pixel. Each pixel can be of any available colors that is supported by device. In the most simple way, it is binary, so it can be black or white. So encoding in this case will be 0 or 1. It can be more detailed, grayscale, for example, in diapason, 255 values of grayscale, but it is still black and white. And it can be full color with different depth of color. And for that, we need 3 or more channels. Which channel is encoded like this. So theoretically, in this case, we have 3 independent pictures or layers for each channel. If we take this as an input, we need to come up with some way how to use this image as a parameter for some mathematical function. This function knows nothing about this structure of layers and blah, blah, blah. It knows just something about many parameters function can get. For example, our mathematical function can get some x. I will mention why I use x capitalized. And for example, the output of this function can be class of the object represented on the photo. For example, this function can be 0 or 1 if we have human being on this image or not, right? This task is called classification, and it's more detailed application is like object detection. We detect whether the object on the photo or not. If yes, the output of function should be 1. If no people on the photo, 0. And this is just a mathematical thing. So what is x here? Does anybody have any guesses? What is the x here? How this can be this?
Some kind of a matrix.
Sorry?
Kind of a matrix.
In fact, if we have in each cell here some value in between 0 and 255, it means we can, this x represent like long vector. We call it vector, but it is in fact a long array of values. Each value is like something 124 or something in between, inside this range. So we take this row, this row, this row, this row, and for all other parts of the image, all the rows, we put them in one long line and consider this thing to be just a math vector. Of course, we remember the shape. This, and this. This is 3. This can be, let's say, 500. This can be 300. So the size of our vector will be 300 times 500 times 3. This is number of channels we use. If it is grayscale, it will be 1. If it is RGB, it's 3. But of course, it can be something more. And this is the size of the picture. So final length will be quite big, but it is still just a vector. And for this type of variables, we use capitalized letters. So this big X means like entire set of values. Small x would mean like just one value. With index, of course, here. So if we have this vector and feed this vector to function f, we can get 0 or 1 as a result. What we can do with all that stuff for real images? For example, we can easily detect for now characters. Let's say we have something like this, handwritten 7. And of course, in pixels, it looks differently. So we have some pixels black. some more, but it is still 7. Yeah. So as an input, we can take all these values of all these cells, and finally find some type of function that will tell whether we have 7 on this picture or not. Yeah. And neural network isn't the only thing that can do this. Previously, like maybe during quite long period, neural networks weren't the main tool to do that. Currently, of course, we can easily do this with neural networks, but instead of that, we could potentially use a thing called logistic regression, for example. That takes part of this 7th as a vector. We already know that it is big X that goes with each cell here to be original pixel value. Feed this X to a thing we call logistic regression. Logistic regression can be explained with 2 parts, like all the values from this vector that we collect as an input, make the sum of them, add some bias. This is just a sum of these inputs with coefficients. This is some bias, and then finally apply some mathematical function to this and get the output that will tell us, is it does the picture contain 7 or not?
What's bias? It's like an error.
Sorry?
What is bias?
Bias is something that shifts the value. It's general method. It's just a number, just a scalar value. That's it. Generally, in math, you maybe remember that if we have equation of line, let's say this is something that describes the angle of a line, and this is bias. It shifts line from the 0 value here. So in multidimensional space, this is the same, but we have many coordinates here. Like this is just for 2-dimensional space, but we can also have this function in multidimensional space. And actually, what it is like. Logistic regression is a classification algorithm. We will talk also about classification things and regression things, and we'll find the difference between them. But generally, we can use very simple mathematical formula to understand what is this 7 or not. In order to make this function work, we just need to know all these small coefficients here, like a I, x, I. If we know all the a's and all b, we can apply this function and understand what's the value of entire sum, and finally make a decision. I will tell more about this function sigma function later. Sigmoid. So this is very simple linear function. And it is possible to find corresponding A's and B's to make it quite accurate about understanding whether we have 7 in this picture or not. But what if we have much more complex input? If we have like something like cats and dogs, and we need to be able to distinguish them. This is a very linear and consequently very simple hypothesis about how we can detect numbers or objects on the picture. So what I want to tell here is that we have many different algorithms. Some of them can be used for this type of data. But if data becomes more complex, many more complex features appear on the photo. For example, how human being understands is it a cat or dog on the picture. Generally, we distinguish cats and dogs by observing the shape of paws, like maybe an eye can be different, the ear, many small things in appearance can be different there. And such a simple model cannot understand the difference between okay, simple cat has this type of an eye, right? Dog have different type of an eye. Human being can understand that, but this approach can be used to understand very, very simple things. Do we have the set of pixels like that or not? But this type of feature, like this shape of an eye, cannot be explained just in pixel positions, because it can be in different parts, it can be on a different angle, maybe different scale, so that we need models more like not linear, more sophisticated, that can count more complex features. And this is what we are going to discuss about neural networks. Now we have to set a short break, maybe 15 minutes, and then we'll be continuing. Okay, so this link supposed to be like a satellite link for thing I called logistic regression before. It explains some mathematics about that. I'd say exhaustively explains what is logistic regression with formulas and so on. There is no real need to go through this document in details right now. But when we will be mentioning logistic regression in the future, we will be doing this a lot. If you want to understand it better, you can take a look at this document. It's nice about that.
Some seem to be not full. There is nothing underneath gradient descent, derivatives, empty cells.
You can press the, oh, I see. Okay, so I won't be spending time now checking why it is like that. When we have a break, I will check this document again and understand why they don't all open. But the theory part here is complete. Just for notes, if we need. So. Starting from this moment, we will switch from business applicability to some more detailed machine learning discussion. And what we need to understand before I continue is different types of machine learning that we will be applying for our computer vision things. And it is important to understand what is classification. You might know already what it is. What is regression? What is neuron and neural network? What other machine learning algorithms can be used for classification and regression? And why we don't discuss them a lot? And one important thing, we are talking about predictive models. We are talking about algorithms that can some guesses about what we have on the picture or what the dollar exchange rate is going to be tomorrow, or what is weather forecast for tomorrow or something. So everything we are trying to do here is just to make some predictions. Predictions is the thing that can be done with some kind of confidence, but without sureness about for 100%. We can do any guesses with some accuracy, but not like completely 100% accurate all the time. So if we have a photo with cat, maybe we can design an algorithm that in 99% cases detect the cat, but also it is possible to find a picture of cat that won't be handled by our algorithm perfectly, right? So all the time we face with algorithm that recognizes something. This algorithm still has some weaknesses, and this like how well this algorithm performs and what is the weak point and what is the measure of accuracy of this algorithm can be done by proper evaluation. And for anyone who wants to design any business based on AI should understand that the most important thing in technical perspective that you will be fighting for is nice metrics obtained by evaluation. Evaluation gives us accuracy and quite big range of different metrics that can show the quality of your solution.
how perfectly we can find people on the image, how perfectly we can see the building from the satellite, how well detailed output we got. Everything is about evaluation, accuracy, and metrics of quality. So evaluation and quality testing. And of course, all the machine learning things, they cannot exist standalone. They should be wrapped inside some software solution. So it is also about programming and possibility to wrap this AI inside something that you can launch on your iPhone or PC or somewhere, even on drone. So So the first thing, classification, and the second thing, regression. Almost all the machine learning we are talking about is about supervised learning. I'm writing it down into a document I've shared with you. You can have this document all the time open so that you will be able to see terms I want to leave for you or links. So classification is a thing that returns to us any binary decision based on input. For example, if we want to know is there any person on image or not, we get 0 or 1 as an output of our predictive model, and this is just a classification. We can distinguish apples from cherries or something like this, and the goal is to detect class. Regression, it is also predictive thing, but for example, if we have a person on the photo and we want to be able to estimate an age of this person just by face features, and age is something that can be represented as a number, even float number, right? Age isn't something that can be binary, like age or not age. It is 37, 52, 12, something. So it's continuous value. So classification provides binary thing. Regression provides continuous value. In general, binary, it's like 0 or 1, or the value from the fixed set of values. For example, if we have to be able to classify animals like cats, dogs, deers, and let's say birds, we can have 4 different classes for them. Call these classes 0, 1, 2, 3, respectively, like cat, dog, deer, bird. And our system will generate one of this number when gets picture as an input. Here is a picture of some animal, and our system produces one of these values. This is classification. Can be binary or multi-class classification. About regression, it is age for person, maybe exchange rate for dollar for tomorrow. Also, it can be temperature, average temperature outdoor or something. Both this machine learning tests, this and this, they are known to be part of supervised learning. And the reason why they are called supervised learning is that in order to be able to build such a system, we have to prepare some training data, some training examples that we will show to program, and program will learn the knowledge how to distinguish cats from dogs, or how to predict continuous value from data, so that we need to have some examples. This photo contains cat, this photo contains bird, and so on. For regression, this is the photo of 32 years old woman. This photo is the photo of 90 years old guy, something like this. When we have many examples like this, we can build the algorithm that will try to understand what features on the photo are informative about that, and we can utilize these features to predict, to say, this guy is 90 years old. In real life, we can build system that will detect the age of a person, of course, with some error. For example, if error is small, we can say, okay, this is approximately 20 years old guy. In fact, it is 19, but it is close, and this guess is much better than not having any guesses. Is he 19 years old or 50? So this is the question of accuracy, how big the mistake is. But generally, all the machine learning tasks, they are about reducing this mistake in our prediction. So supervised learning goes together with and this couple of problems can be solved with many types of algorithms. Throughout the history, there were like many popular state-of-the-art technologies, like support vector machines, naive bias algorithm, and so on. There are many, like hundreds of different algorithms that can get the vector of input x's and make a decision. But for now, currently, the most powerful and the most practically useful and universal algorithm that can do both things nice on very complex inputs is neural networks. Neural networks is an approach that allows us to use simple predictions in a simple way with simple computations, or very, very complex predictions based on like many computations on many different small features from the photo, for example. So we are not going to talk about this at all because we don't have time for that. But there are many nice things that you should be aware of. Support vector machines for classification, support vector regression for regression tests, and so on. Please, to learn about that, if you want, there is an extremely beautiful book from Peter Norvig. It's an abbreviation. Artificial Intelligence Modern Approach. You can Google this thing, and it's like nice explanation about all these algorithms I mentioned here. Also, this book mentions neural network as one of available algorithms. But now we rid of this part. And let's talk a little bit about evaluation. Let's suppose we are developing business and want our cameras in shopping mall to detect people. How many people we have in which areas in the shopping mall? For example, our marketing department wants to know how many people usually stands by this vegetable part at 8 o'clock in the morning or 12, just for some business important analytics. And we have a shopping mall plan, different areas here, like maybe this is a vegetable area, this is might be milk or bread or something. Let's have 3 areas, right? And our system tries to understand how many people we have here, here, and here. But the thing is that, in fact, our cameras, our solution can see people, but not perfectly all of them. Sometimes people can be have overlapping. Some person can be hidden from the camera by other people or something like some another object, the shelf, for example. Sometimes person has a pose or very weird clothes that makes our system blend about him, about this person. And this reduces our ability to be very accurate. Sometimes we will be losing and not see people. And this means that we have not 100% accurate system, but if we do well enough, maybe this mistake of our estimation, how many people we have in vegetable area, is something that still works nice for business. And here we need to have some system that will measure the quality of our detection. For example, if here we have 300 people and our system detects 260, for example, with 40 people mistake. And here we have 13 people, but our system says it is 20. It is not accurate, but for business, it is still can be used, right? It's my guess. Maybe there is another threshold where it is okay or not, but generally some error is on one hand it is expected, on another hand it is not a big problem. The level of accuracy is something that we need to describe before we start our engineering something. So we need to reach the goal of 90% accuracy or 80% accuracy. But this number of accuracy should be calculated, computed in some way. And this is everything about evaluation. For example, for any businessman, term accuracy seems to be intuitively clear. Like everyone understands the idea of accuracy, but in math world, it is still very formal thing what this accuracy is, and it can be very different. We can formalize what type of accuracy we need. For example, if we have like just a goal to understand how many people we have in this area, and we make some mistake instead of telling that there are 300 people there, we predict 260. So what's the accuracy in your opinion for that situation? Who can guess? 300 people. In fact, but we detect do you have any guesses?
Like 80%.
Why 80?
Just first guess.
So, okay, let's simplify. If we potentially have 100 people there, but we say that we have 92 people here, the mistake is about 8%, right? And accuracy seems to be about 92%. And this is accuracy, but types of accuracy can be very different. And what I'm going to provide you is the understanding why this number of accuracy is something that doesn't tell anything important to people. Accuracy is a fake thing. There is no such an informative thing as accuracy, because, for example, we have to develop a system that that is able to distinguish coins 5 cents and 10 cents. Okay, we have examples of different coins, and we write an algorithm, and our cheating engineer he decides to write a function like this. Oh. And so this thing all the time says that we have all whatever we get as an input. In fact, system says we have 5 cents. And the problem with accuracy here is, let's suppose we have 1,000 coins. But what if among this 1,000 or 10,000 coins, we have only 5 10-cent coins? if we take all these examples and feed to this function, as a result, we get this number of correct answers and this number of incorrect answers. And the accuracy seems to be like 99.5%, right? But it's completely clear that this is absolutely fake solution. So with accuracy, we always should be very careful. When you have a team of engineers who are working on a solution in machine learning, and they say something about accuracy, you should understand that they can talk about something like this. It can happen not just because of they are cheaters, but also because of some situation they didn't expect. For example, they expected that they have good balance between coins in their data set, right? But in fact, they got very imbalanced input. Many 5-cent coins and too few 10-cent coins. So even for them, sometimes it could be not easy to understand what is accuracy. So business optimizes accuracy. But this accuracy isn't the thing that really nice descriptive. So for all businesses who work with data and machine learning, it is crucial thing to understand what exact metrics business should use for estimating the performance of solution. Is it clear why?
Yep.
This comes from like poor balance, but there are many cases and many other reasons why accuracy could potentially not work. And unfortunately, this is the point where even absolutely isolated from mathematics businessmen should dig in depth to understand nature of metrics of this thing. Whether it is face recognition, gender detection, or stock exchange forecasting, all the time we need to understand what's the matter. And this evaluation thing is an absolutely independent big topic of machine learning. And when you build a solution, you should you should personally think of that and talk with your engineers about proper way of measuring the quality. And let's give up discussing accuracy in details like this, and just an example how we could in fact compute this accuracy for classification in general. So generally formula for accuracy would be like correct number of guesses divided by correct by plus incorrect, or all the number. Easy, right? But can still contain many mistakes. So this evaluation is important. In our Jupyter notebooks, we will have several different metrics for evaluation. We will still use accuracy because it is something that easily understandable by human. But also we will use other metrics that are much more robust for things like skewed data set or something. So we will use F1 measure, precision, recall. It's general, like common abbreviation for that. Let me just put these abbreviations here. We will cover this when we will be trying to understand one of the notebooks. Yes. And this is for classification. For regression, we want to know how exchange rate will behave during the month, for example, right? We want to know what is going to happen to exchange rate during the March. This is days, and this is exchange rate. And this is exact value. So we take some market information, we can take current exchange rate and try to predict the form of this curve for the future. And we predict something like this. Is it accurate or not? How we can measure accuracy for this thing? For regression, we predict values, not like binary things, continuous values. So the only thing we can do about this is to take a look at every small error we got in our prediction and try to find some value that characterizes predictive ability of this model. Usually we use like square root of quadrats of some of these things. It can be called, we can use standard deviation. Or something similar. There are many. This is like the most popular. Also, minimum square error or just square error. So, about these formulas, we'll learn more during the learning examples. So, before we switch to this, let's discuss software engineering things. And our solution about machine learning can be a piece of Python code that can be used from console, from Jupyter Notebook, but in fact we need this to have on our website or application or inside Android or iPhone. And in order to do this, we also need to have some engineering expertise, how to put this part of predictive math inside application. And the problem with that is regular common software engineer usually doesn't face with situations when he need to take real mathematic bound thing and integrate it inside the application. It is like additional level of expertise that requires to understand what is TensorFlow, for example, what is Keras, what is GPU. Good question. We'll tell about. We'll discuss this GPU related things. How this can be put into software and what's the specific of hardware we need to make it work, and so on. So software engineering for machine learning project implies some additional expertise that is specific to machine learning things, because model, the thing we mentioned many times already, it is something that can be explained like model is a piece of code that can also use some coefficients, some binary data saved in some file or in computer memory that contains knowledge about what to do with data. And this model can be used for predictions. But for software engineer model is a Python class. For scientist model is an idea and several coefficients saved somewhere. So deploying the model and designing the solution that uses this model is a separate thing, and for that we need to hire proper people or like develop our own expertise. Yeah. So it's not just I think when we can ask general coder to do some machine learning based solution for us. First of all, we will probably need data scientists who will be doing this research and model preparation, and also software engineer who is familiar with machine learning ecosystem. Switching to neural network, neuron, and surprisingly to logistic regression again. All the data scientists use this term all the time, even ignoring the fact that nobody else understands this thing. And they know that logistic regression is something that is a core thing for neural networks, because logistic regression is actually neuron and blah, blah, blah. They understand that, but people who they talk to don't understand what is that logistic regression. So if you ever will have any things with data scientists, they will be mentioning logistic regression all the time. And unfortunately, this is not regression in general. Logistic regression is a term that actually is an exception. Logistic regression is a classification algorithm. It is not regression algorithm. We discussed that we have classification thing in supervised learning and regression thing, but we should understand that logistic regression is classification. And I'm starting to explain neural networks from the idea of logistic regression a little bit in more details. Then I switch to idea of neuron and to simple neural network. Then I briefly explain what it means to train neural network. And this is going to be all about required mathematics for that. I will try to be less scientific bound, more like popular explanation about that. So if we have to design a system that detects whether we have zeros or ones on our image, we can, if we want to do this, we can use simple logistic regression. The problem is quite simple, so logistic regression could be nice choice for that. So let's try to come up with such a system. Okay, do you see the board? Is it okay? Okay, yeah. So let's say we have picture like this again. So sorry, need to draw it better. We will be using grayscale. So each pixel can hold the number in this range. And currently we have 8 for 8 pixels. So we have 64 values in vector x. Is it clear how we got this vector? We already discussed that. Each value is 0 to 20. So we take this vector and let's rotate it. In math, we call this transpose. And we have many small x's here. This is, for example, x2. Is it clear that this is x2? Why it is
Yes.
not x3.
Because we start with a 0.
Yes. Yes. To remember.